Okay, let's take a look at number one. We are looking first of all at the graph of f prime, so make sure that we are aware of that. The graph of f prime, the derivative of f is shown for the closed interval -2 to 5. On what intervals is f is increasing? So again, f is increasing whenever f prime is greater than 0. So f prime is greater than 0 on here and here. So we need to look at that interval from -2 up to +3. And if we're going through here, that would be B. Number two, the second derivative of the function is f is given by f prime equals x times x minus a times x minus b squared. The graph of f double prime is given above. So again, just make sure you are aware of that. And we want to know, where does f have a point of inflection? Well, f has a point of inflection whenever f double prime is 0, which happens at A, which happens at the origin, and which happens at B, and changes sign. That means it goes from positive to negative, or from negative to positive, which it does at A, where it goes from positive to negative. It does at B, or sorry, at 0, where it goes from negative to positive, and it does not at B. It goes positive on the left, positive on the right. So the answer is A, only at 0 and A. Question number 3, for all x in the closed interval 2 to 5, the function f has a positive first derivative. Okay, again, positive first derivative means that the function is increasing, and a negative second derivative, which means it's concave down, or that f prime is decreasing. Which of the following could be a table of values for f? So we're looking for a function that's increasing. So the values in A are increasing, B is increasing, C and D are both decreasing, so they are out. And what we're looking for is a decreasing change, a slope. So the change there, as long as the x is changing by this an equal amount, we can do this. So the change here is 2, the change here is 3, the change here is 4. That means that second derivative is positive. It's concave up here, so A is out. Let's verify this. This is a change of 4, a change of 3, a change of 2. And so B is going to be our answer for number 3. Question number 4, let f be a differentiable function such that f of 0 is -5. F prime of x is less than 3, so that means, again, the change in f is less than or equal to 3 for all x. Of the following, which is not a possible value for 2. So again, I prefer tables of values. So if I start here, that means 1, if the change is going to be less than or equal to 3, then that means this value here, -5, must be less than or equal to -2. And therefore, when I go up to 2, that change, if I add 3 to that, that change must be less than or equal to 1. And so all of the answers that are less than or equal to 1 are satisfactory. So D is the one that cannot be a possible value for f of 2. All right, let's take a look at question number 5. Question number 5 says the figure to the right shows the graph of f prime of x. So again, make note of that. We're dealing with f prime. The derivative of the function if f of 0 is equal to 0, which of the following could be the graphs of f? So again, first note that all of these functions have f of 0 equal to 0, so that satisfies that one, so we don't have to worry about that. Next, let's take a look at f prime of x. There's a couple different things we can do. I'm going to start with saying that f prime is positive from 0 to 2. That means the function is increasing. And I'm just going to stop right there. This first graph, A, does not increase from 0 to 2. Neither does B. B increases from 0 to 1. However, both C and D increase from 0 to 2. F prime is negative, which means the function is decreasing between 2 and 3. And sure enough, both C and D do. And then f prime is positive, which means the function is increasing from 3 to 4. And again, both number 3, or letter C and letter D, do that. So the question now is, how do we differentiate here? All right. Well, if we take a look at these two graphs, the main difference is if you take a look from 0 to 2, this is going to be concave down, which means the second derivative should be negative. Or if we take a look at the first derivative, that means the first derivative, f prime, is decreasing. Here, the function is concave up from 0 to 1, which means f prime should be increasing. And if we take a look at our graph here, f prime is increasing from 0 to 1. So that means the function is going to be concave up. And then it's decreasing from 1 all the way to like 2.5. And if we take a look, this function is going to be concave down from 1 all the way to about 2.5. And so C is the answer for that one.